Hey there, this is Fuzzy Data for Decision Making, a software to resolve a particular kind of problems that every person or group of persons have when they try to figure out what's the best option available for a problem that requires a solution. And it's my final test to become an informatic engineer. So first of all, let's see what parts or data theories were needed to develop this. The whole project is based on the development of a method that allows us to create problems, which data structure we will watch soon, and get results from it. So for this development we need to know about the fuzzy data theory and the decision making theory. Fuzzy data or fuzzy logic is a way of using diffuse maths to represent real expressions that cannot be quantified so easily. This means that this theory allows us to represent value judgments that a user makes when this one tries to magnify something. For example, sentences like wrong, right, less, more, high, low, or whatever. The way that we can use this kind of maths is by using the fuzzy numbers. These fuzzy numbers are numbers arrays that represents an expression. The way that this math works is by using geometric areas of geometric shapes. And we could use any of them. We could use triangles, we could use squares, we could use ellipses, circles, pentagons, anything. We could use any shape that we want, but there is a problem. If we use hexagons, for example, we need a 6-length array to every expression. This should work as any shape, but it would be unnecessarily complicated. The best is using 3-length arrays or 4. In this case, we will use triangles. So, for example, if we want to differentiate the triangles low, medium, and high, we should use something like this. As you can see, the 3 components of these triangles makes one of them more bigger or lower than the other one. And in this way is pretty simple. So, now that we understand something a little bit about fuzzy logic, let's see some decision-making logic. We will see here some similarities with the big data management for this data mainly apply. This is because when a group of persons have to choose one of many alternatives to solve a problem, they have to use criteria for it. These criteria, in an organization for example, comes from its history, its norms, its objectives, its first steps, and all this can come from a process like data mining. So, for apply this theory to our method, we need to set the following components to make it happen. We need the decision makers, that we will call the decisors. We need criteria, which are the start points of evaluation. And the alternatives are those possible solutions to our problem. So we need the decisors to set their own weights, the decisor weights, make criteria comparison, and classify alternatives based on criteria. This means that decisors need to differentiate between them, because there could be an important decisor on the group, or a normal decisor, or maybe just the one that is the most important of them. We need criteria comparisons of every decisor because we need to know which one of them are the most important to the rest of them. And finally, we need the evaluation of every decisor to the alternatives based on the criteria. So now let's talk about the method itself. All we just spoke about decision making could be our part one of the method, when the user loads all this info to the method management. And the second part pretends to follow a few steps to manage this data and get the solution that we want. So let's talk about this second part. So these are the method steps, are 12 steps that allow us to get the solution, because once the method gets the solution, this will show us a rated table with the alternatives. So, for example, let's assume that we got a software company and we need to add a new programmer to our team. We know there are 3 persons who are responsible to solve this problem. And let's assume that 3 candidates want the job. For making a decision, our 3 decisors have to set these criteria. So the criteria are emotional stability, oral communication skills, personality, experience, and confidence. According to the method, each decisor must differentiate between each criterion in order to obtain the relevance for the final decision of the problem. So here are the comparisons of decisor 1. As you can see, we cannot differentiate a criteria with itself. And for this decisor, the criteria C1, that is emotional stability, has a weak importance compared with oral communication skill, which is C2. And oral communication skills, that is C2, has a strong importance compared with emotional stability. Then we have to do the same thing for all of them. Once we have this, the method gets the consistent weights of each criteria, as we can see on this JavaScript array. Remember that these weights or values are triangles, so we need 3 values to represent it. Now that we have classified the criteria, we need to go forward with the alternatives. On this case, every decisor has to set the weight of each possible program and compare it with a criteria. For example, here for decisor 1, the candidate 1 has a medium weight based on emotional stability, and all the same for the rest of the alternatives. Well, finally, we will set the next weights of the decisors, because we need the decisor weights. So if we go to the method, I have to start my server. Alright. Now let's go to the method. Right, so we are here, and we have here all data of our example already loaded. Once this is done, all we have to do is press on calculate results and we will get our solution. So here I will show you. Those are our decisors weights, our criteria comparisons for every decisor, and every alternative with the respective decisor and the respective criteria evaluated. Right? So now we calculate results, and now we got that candidate 2 has a biggest coefficient. So let's resume our presentation. For calculating results, method use distances between the fuzzy numbers using the first math form. So this is the distance between two fuzzy numbers. Then methods establish a number that is 000, as we can see on the right, is the lowest fuzzy value, and 111 is the highest. So the method calculates the best distance, so the method calculates the distance between every alternative to the lowest and the highest value. With these two values, we calculate finally the coefficient for all possible solutions. So the solution that is closeness to the highest value and remote to the lowest will be our best solution. So in this case, as we saw in the method, it is candidate 2. So that's all. Thank you for listening.